Okay, so now we'll look at the hybridization in three different molecules. So the first one is going to be ethane, which has the Lewis structure as shown. If you look at the hybridization of each carbon, you count 4 bonds, and 4 bonds around a carbon corresponds to sp3 hybridization. So in the next shot, you see carbon with the 4 sp3 hybrids. That's 4 sp3s per carbon. And each of those contains an electron. So the idea of a bond forming is when 2 of the sp3 hybrids overlap, and that's referred to as a sigma bond. So this direct overlap of orbitals is a sigma bond, and the same thing happens with each of the hydrogens which overlap the other sp3 hybrids. So in this example we have a total of 5 sigma bonds. One of the things is for a sigma bond is you can have rotation around a single bond. Okay, so this one is ethylene, C2H4. If we count around the central carbon, we count 3, and that corresponds to sp2 hybridization, and here's the trigonal planar form that represents that. So then the bond forms when you have 2 sp2 hybrids that overlap, and that's a sigma bond. So far we have 1 sigma bond which is located between the 2 carbons, and then the hydrogens will bond in the other sp2 locations. Okay, so in this example we're going to end up with 1, 2, 3, 4 sigma bonds, but that still leaves another orbital for each carbon that wasn't hybridized. So in this representation these are called PZ. Now those can overlap, but their overlap is side to side. So this side to side overlap, which occurs in a double bond or a triple bond, is referred to as a pi bond. So each of those 2 red lobes together are referred to as a single pi bond. Okay, in acetylene, if we count around the carbon, we have 1, 2, so this is going to be sp hybridization. And we're going to have the direct overlap between the 2 sps. So that's a sigma. And then we'll have the hydrogens that overlap the other 2 sps, and those are 2 more sigmas. Okay, so that leaves for each carbon 2 more half-filled orbitals that are non-hybridized. So just like in the previous case, what happens is those orbitals which are oriented at 90 degrees to each other overlap. So they're referred to as 2pz and 2py, and then they overlap, and each of these overlapped orbitals represents a bond. So you have, in this case, 1 above the plane and 1 below the plane, and that means that you have 2 pi bonds. So with acetylene you have a total of 1, 2, 3 sigma bonds and 2 pi bonds.